Hi, class. All right, so yesterday I had you guys create a spreadsheet calculator that would address the Newton's law of universal gravitation formula, where the force of gravity is equal to a constant, the constant g, times the mass of the first object times the mass of the second object divided by the distance squared. And the point of that spreadsheet was to be able to take those three different variables, the force, the distance, and the mass, and rearrange the equation to solve for any one of the variables. So I'm going to briefly go through what should have happened because there were a couple of misconceptions that happened, and I want to make sure that you guys are aware of how to fix those. So first, let me go over the exit ticket question. The exit ticket had you change the mass. Well, actually, hold on. Before we do that, let's kind of code our calculator. First, what we want to do is put the mass of Earth in. That's what you're supposed to do. So we're going to look up here at our table of contents. We're going to notice that the mass of the Earth is 5.97 times 10 to the 24th. So we'll take that value and do 5.97 times 10 to the 24th. And then we're going to put the mass of the Moon, which is 7.34 times 10 to the 22nd. And then the distance between them. The distance between them is 3.84 times 10 to the 8th. Now we want to, these blue boxes are for coding. So you should never put any actual values in here. What you need to put in here are codes. So to get our distance squared, we're going to we're going to say equals, we're going to reference the cell right above it, the distance cell, which is D17, and we're going to square that value, raised to the second power. That way, whenever I change this number, this will be the square of it. So if this is 5, this is 25. If this is 2, this is 4. If this is 3, then this is 9. But again, we want the distance of the moon, so it's 3.84 times 10 to the 8th. And the square of that is 1.47 times 10 to the 17th. Now we want to put in our value for g. That equals our constant, and that is located up here in cell G4. So all we need to do is reference G4. We're going to say this is equal to G4. And then boom, that number automatically populates in there. Next, we want to do the force of gravity equation, and that is equal to, first we have an equal sign, that is equal to D19, which is our gravitational constant, multiplied by the first mass, which is stored in D15, multiplied by the second mass, which is D16, and then we're going to divide that value by the distance squared, which is stored in D18, right? So now, because this is code, whenever I change the values in these yellow boxes, this number will automatically get updated. So if I wanted to change this to 2, then it gets changed. If I wanted to change this to 100, it gets changed. So that's how that works. I'm going to go back to our normal thing. And we should find that the force of gravity between the Earth and the Moon is 1.98 times 10 to the 20th. All right, so I'm going to come over to our second table and figure out how to do this one. Well, our mass is still the same. It's 5.97 times 10 to the 24th. Mass of the moon is still the same, 7.34 times 10 to the 22nd. And now we're going to put the force of gravity in here, which is what we solved in the previous problem. So we'll use that number, and we're going to write 1.98 times 10 to the 20th. Now again, these yellow boxes are only for inputs. So in the yellow boxes is where you'll be putting actual numbers in scientific notation. G, we're going to reference the value G, which is stored in G4. So we're going to write equals G4 right there. And then the distance between masses, we need to use our next formula to solve for that, and that is going to be the square root. This equals the square root, oops, SQRT, square root of G19, which is big G. Let me put this in parentheses actually. Yep, I'm in there. G19 times G15, which is our mass 1, times G16, which is our second mass, mass of the moon, and we're going to divide that by G17, which is the force of gravity. And if you'll notice, let's see, did that come out right? No, it didn't. Let's see, hold on one second. Oh, I see what I did wrong. I put the parentheses too early. I should do the parentheses of the whole thing. So I'm going to come up there, and I'm going to change my parentheses, and there we go. And if you'll notice, the distance between them is the same as over here. But this one we've actually written in the number, and here we've used the code to calculate it. So if you look up at the formula bar, notice how the values are the same in the cells, but in the formula bar, I have code in this one, and then if I click on here, I have the actual number. So again, those yellow boxes are for the actual number, and the blue boxes are for code. All right, so in our last table, here's where things get tricky. Again, I'm not going to tell you exactly how to do this because I'm going to consider this a level 4 assignment. Um, the yellow boxes are for input, so we can do that. I can help you with that. The force of gravity is 1.98 times 10 to the 20th. The mass, we'll say the mass of the moon is 7.34 times 10 to the 22nd, and the distance between them is 3.84 times 10 to the 8th. So now that we have our inputs, we need to figure out the code. So the distance squared, that's going to be similar to this code, which is d equal to d17 raised to the second power, but I don't want to use d, I want to use this column, which is j. G, you'll find G using the exact same way, and then to find the code to calculate it, what you need to do is you need to take the value that's stored in distance squared, multiply it by the value of f and g. So you're going to have distance squared right here. That's going to be in J18. You want to multiply that by the force of gravity, which is J15, and then divide that by the product of your g value times your mass value. And so it's going to be tricky, but I think that you guys can handle it. If you have problems and you really want to solve it, let me know. Send me an email, and I can help you out a little bit more. But that is a level 4 problem, so you should be able to figure it out on your own. Okay, so some other things I want to make sure that we are taking care of is I want to go over the exit ticket question. So in the exit ticket question, I'm having you change the inputs on this table number 2. So instead of doing the finding the force of gravity between the mass of the Earth and the mass of the Moon, I'm giving you a couple different options. I'm giving you different masses. So I'm going to erase these values because we're going to start over. Mass 1 is going to be 7.23 times 10 to the 14th. Mass 2 will be 7.29 times 10 to the 16th. And the distance between whatever these masses happen to be is going to be 5.05 times 10 to the 8th. And if you enter these incorrectly, you'll get this value, 1.38 times 10 to the 4th. So this is how many newtons are between these two masses at this distance. Now remember earlier we figured out that if you increase the distance, then force should go down. So let's make this distance bigger. We're going to see if this number gets smaller, right? So instead of 5.05 times 10 to the 8th, let's do 5.05 times 10 to the 12th. And let's see what happens to our force of gravity in D20. There you go. Look at that. Now it's a very small number. It's 1.38 times 10 to the negative 4th. So it's 0.000138 newtons. It's a very small force. Now let's bring these things really close together. Let's make them 1 meter apart, and let's watch what happens to the force of gravity. Oh my, it shoots up a huge amount. So when these two masses are next to each other, it's a huge mass. It's a huge increase. Okay, what else did I want to Okay, so I think that's all I wanted to talk to you about. I just want to make sure that you're aware that the blue boxes are for code and the yellow boxes are for inputs. So once you have the code in these blue boxes, you're not going to touch it. You're only going to have the yellow boxes for inputs. So in our upcoming problems, the problem set you're going to be getting today, you're going to be changing the values that's in these yellow boxes. But as long as you wrote code in these blue boxes, then you should be fine. A lot of you guys wrote the actual numbers in these blue boxes, which would make this calculator inoperable. It would be doing nothing. The whole reason this calculator exists is because it takes the information in the yellow boxes and then calculates it using the code that's in the blue boxes. So if you just wrote the numbers in the blue boxes, you'll have to go back and fix that information. Okay, so email me if you have any questions as you work through the problem sets, and I'll be around throughout most of the day to help you out.